Volumetric analysis. As we have told you that volumetric analysis carries 10 marks. This is your first experiment. So you will be preparing, you will be asked to prepare 1/10 molar more salt solution and determine the strength of the KMnO4 solution using that solution. So your more salt solution will be the standard solution and your KMnO4 is the unknown solution. It is a redox titration in which the KMnO4 is acting as an oxidizing agent where it changes, where it itself gets reduced from +7 oxidation state to +2 oxidation state, and more salt from that is which is a double salt, which is a mixture of ferrous sulfate and ammonium sulfate with 24 water molecules of crystallization, gets oxidized from +2 to +3. So it is a redox titration. Here we are going to you are going to prepare the more salt solution, which is called the standard solution. A standard solution is the one whose molarity or concentration is known to us and which does not change its concentration when kept for some time. We call these kind of solutions as primary standard. So here you are asked to prepare the more salt solution. So what will be your aim? How to present the paper in the board. That is what I am concentrating now, as well as you will get the procedure as well. Now just see, to prepare, what will be your aim? You will prepare 1/10 molar more salt solution and then you will be determining the strength or the molarity of the given KMnO4 solution. So what is the theory behind it? Theory is the principle, that is, it is a redox titration, right? So you give the equation next. So what is it? You can here the ionic form of the equation is given. Permanganate ion and this more salt, that is iron Fe2 plus. In the acid medium, you will be adding sulfuric acid as you see in the experiment. So permanganate plus Fe2 plus plus H plus from the acid will get reduced to Mn2 plus. This gets oxidized to Fe3 plus and 4 water. The balancing part is very important, and this equation will carry 1 mark. That is, you will be getting this is the theory, that is what is happening. This is the equation or the reaction that is happening. Then after you give the equation, then we are going to prepare. You know, now you are asked to prepare what? 1/10 molar of more salt solution. So when you have to prepare, then you have to know how much you have to weigh and how to prepare it, right? So how much to weigh and how much to take weight. So you know that, all of us know the formula. It's a double salt, I told you. It is ferrous sulfate, ammonium sulfate with 24 water molecules of crystallization. When you calculate, the molar mass of the substance comes up to 392 grams. The gram molar mass of this is 392 grams. So we know that 1000 ml of 1 molar solution of the more salt contains 392 grams of the more salt. So we have to prepare, we are giving you a 100 ml standard flask. So in the 100 ml standard flask, 1/10 molar should be prepared. So you calculate accordingly. So 1000 ml contains 392 grams for 1 molar solution. Therefore, for 1/10 molar and for 100 ml, your calculation comes up to 3.92 grams. So you will weigh in the balance 3.92 grams, and this calculation is to be shown first. How much have you to take? So after calculating this, you are supposed to weigh in the balance. So this has to be presented. This is the order in which you will present in the board. So 3.92 grams of more salt to be taken. So that will be shown. Then we are coming to the procedure. You don't have to write a lengthy procedure as you have written in the journal, whether to wash the burette and all. But it is necessary that you have to mention what are you going to take in the burette or what are you going to take in the pipette. So this you can even give it in the tabular form. So burette solution, I will be using KMnO4. Pipette solution, you will be taking the more salt. In the standard flask, you are preparing the more salt, right? From that is your stock solution now. From that, every time you do the titration, you will remove 10 ml. So your volume will be 10 ml. So pipette solution, more salt, 10 ml. Indicator, what is the indicator being used here? Self indicator it is. KMnO4 itself is acting as the indicator. That is, the reagent itself is acting as the indicator. So I have given there as self indicator. Endpoint. What will be the endpoint? It is when you add KMnO4 to the more salt solution, it becomes colorless, right? So from colorless to permanent pale pink color. Why did I write permanent pale pink color? Every time you add, there is a small time lag for that oxidation or the reduction that is happening. So that time lag, it will appear to be pink, but afterwards it will disappear. So till you get that permanent pale pink color, you should see that will be the end point. Pale pink color it should be. Medium. Before doing the titration, after having pipetted out 10 ml into the clean conical flask, you will add 10 ml of dilute sulfuric acid, which will make the medium acidic. So we are writing the medium is acidic. You have studied in your D block also that KMnO4 is a good oxidizing agent in a acid medium. Okay, so that is the dilute sulfuric acid is the medium here, that is acidic medium, and we are adding 1 test tube or 10 ml you can add. Temperature, we are performing this experiment without heating at room temperature. So that is the room temperature, and the molar mass of KMnO4 which we use in the calculation is 158 grams. Then after having written this, you will go for the observation table. Now you keep everything ready in your paper. So first, as soon as you get the question, immediately you will start writing the volumetric analysis curve. This aim, this theory, preparation part, that is calculation of how much weight to be taken, and then the procedure, and then the observation table to be drawn neatly. So what are the things that are essential? Give the heading for the observation table. It is standard more salt versus KMnO4. Okay, so that heading should be there. And what are the columns that are expected? Serial number, volume of the more salt solution. You will do the experiment 3 times, right? At least minimum of 3 times, so that you ensure your readings are right. So serial number 1, 2, 3. Each time the volume of more salt solution will be 10 ml only. You will pipette out 10 ml and you will add to the clean conical flask. Don't forget to add 1 test tube of dilute sulfuric acid each time. And always your burette reading will be initially 0 only. Okay, it will be initially 0. So you will every time you will bring it to 0 and then only repeat the titration. So your initial values are 0. Final values, after you get the pale pink color, you just check the lower meniscus to be seen for colorless solutions and upper meniscus to be seen for colored solutions. You know what is meniscus? The curved portion of the liquid. So here it is KMnO4 that you are going to read. It is a colored solution. So you can see the upper meniscus which coincides. So let us assume that the value is 10 suppose. So then I will write 10, 10. Suppose all the 3 times I got 10. Then my final values will be 10 ml, 10 ml and 10 ml. Volume of KMnO4 will be final reading minus initial reading. So again it will be 10. Okay. And in the tabular column, please do not forget to write ml, because your unit should be mentioned. If the unit is not there, again you are going to lose mark. What is concordant reading? Concordant reading is the one which gets repeated. That is 2 successive readings which are the same readings. They are called the concordant readings. And here it is 10 that is getting repeated. So my concordant reading will be 10 ml. Right? Then you go for calculations. So once you have finished with the tabular column, please try to get the values attested from the examiner. So attestation means you have to bring the values and get it signed by the examiner. Once the examiner signs your tabular column, then you are ready to proceed with your calculations. So please do not overwrite or cut and write here and there. The tabular column should be very neat, otherwise it is considered to be manipulating the values. Okay, so now calculation. So what is this formula that we are using? Molarity of KMnO4 multiplied by volume of KMnO4, that is the ratio, their molar ratios we call. Molarity of KMnO4 multiplied by volume of KMnO4 divided by molarity of more salt multiplied by volume of more salt equal to 1 by 5. How did I get this? You see your balanced equation that you have written, you will get the molar ratios. So you get 1 by 5. So I substitute these values now. Before substituting, I should know what are the values. So you pen down all the values. Molarity of KMnO4, I do not know, that is an unknown one. So I have taken it as X. Then volume of KMnO4 is 10 ml. That is, I have given you just a sample value. It need not be 10, it can be 10, 10.1, 10.2, anything. I have just taken it as 10. So I am writing that value as 10. Now molarity of more salt, we have asked you to prepare 1 by 10 molar. So it is taken as 1 by 10 molar now. Volume of more salt is the pipette solution. You are pipetting out 10 ml into the conical flask for every time you do the experiment. So your volume of more salt solution will be 10 ml. So these are the values which we are going to substitute in the formula. So on substitution in our formula, X times 10 ml, which is my volume of KMnO4, which I have taken hypothetically, means for an example I have taken here, divided by 1 by 10 molar of more salt solution multiplied by 10 ml of more salt solution which I pipette out. So I am substituting these values. Again I am equating that molar ratio to be 1 by 5 with the help of that balanced equation. Okay. So now you calculate for x. So when you calculate for x, you get 1 by 50, which is equal to 0.02 molar. And one very important thing here is you are not supposed to round off. As much as you round off, your error will increase. So please do not round it off. It can be up to 3 to 4 decimal places. Okay, so please do not round it off to 2 decimal places. Whatever values you are getting, you will have that, and don't forget to write capital M, which indicates that it is molarity. So molarity of KMnO4 is determined to be 0.02 molar as per my value, that is 10 ml as supposed to get on titration. Now we are not only asked to find molarity, we are also asked to find strength of the KMnO4 solution. What is strength? Strength is number of amount of the substance present in 1 liter of the solution. So strength equal to molarity into molar mass of KMnO4. We are asked to find the strength of KMnO4. Molar mass of KMnO4 is 158, and my molarity here is what? According to this, whatever I got values by taking 10 as my type value. So 0.02 molar into molar mass of KMnO4 is 158, which comes up to 31.6 grams. I think 3.16 grams per liter. Okay, 3.16 grams per liter. So 0.02 molar into 158 equal to 3.16 grams per liter. So now I will write my result also. You were asked to find the molarity and strength. So you are going to answer your question now. So final result will answer the question given in the beginning. So molarity of KMnO4 equal to, how much did I calculate? For my value it is 0.02. Whatever you get, you write. Strength of KMnO4 is amount present in 1 liter of this solution. So it is 3.16 as per my value of 10. Whatever you get, you will fill it up over there. So after this result, you will write precautions. What are the precautions that you have to take while performing this experiment? A minimum of 2 precautions is expected. Okay, what are the precautions? You have to wash all the apparatus thoroughly, and burette and pipette to be rinsed with the respective solution. For example, burette should be rinsed with the KMnO4 solution. What is the purpose of rinsing? You should see any water droplets in the burette or the pipette can dilute the solution. Here we are very much bothered about the concentration of the solution. So we do not want it to get diluted. So rinse the burette with the KMnO4 solution. Rinse the pipette with the more salt solution. But please do not rinse the volumetric flask, that is the conical flask, with any other solution. Just wash it, dry it, and then pipette out and do the experiment. And the second one is, do not forget to add dilute sulfuric acid to the more salt solution in the standard flask. To prevent hydrolysis we are adding, as we have seen in the experiment. So please do not add, forget to add that. And also 10 ml of dilute sulfuric acid to be added in the conical flask after pipetting out to make the medium acidic. So the addition of sulfuric acid in the standard flask and in the conical flask is an important precaution. First precaution will be washing and rinsing your burette and pipette with the respective solution. So at least these 2 precautions should be there.